In today's lesson, we are having a look at sigma notation. Sigma notation is another way to write sequences in. Notation means way of writing, and sigma is a Greek alphabet letter. The sigma sign in our notation will mean sum. Then the sequence will not be expanded, but will be written in terms of its general term, Tn, to the right of this sigma symbol. At the bottom, it will tell you exactly at what term value to start. And at the top, it will tell you up to which value to add up. Let's look at a simple example. In example 1, they say evaluate. And because we see the sigma symbol there, we know that we need to calculate the sum of this sequence. But first, we need to write out the expanded sequence. And to do that, we are going to start by substituting in with 1. So it will be 2 times 1, and we're going to continue like that, 2 times 2, 2 times 3, 2 times 4, and we're going to do that up to 2 times 5. That will give us the values 2, 4, 6, 8, and 10, and if we add them up to get the sum, we will get a sum of 30. So instead of giving you your question in a full sentence, calculate the sum of the first 5 terms, it is simply given to you in a new notation. In example 2, they now use the variable I. So this is just so that you realize they can use any letter they want to. Once again, we need to start by expanding our sequence. So we're going to start by substituting I with 1, then 2, and 3, and we will continue like that up to substituting 8. The first 3 terms of the sequence will then be minus 10, plus 20, minus 40. And now we can say that A, our first term, is minus 10. Our constant ratio here is term 2 divided by term 1, which is the same as term 3 divided by term 2, and that is minus 2. Now we can substitute into our sum formula for a geometric sequence. So we are calculating the sum of 8 terms. A is minus 10 and R is minus 2. And this will give us a sum of 850. Example 3 is similar to the first 2. There's just one small difference, and that is that you don't start substituting 1, but you start substituting 3 to expand your sequence. But still, we are starting by expanding our sequence, so we're going to start by substituting in 3 to get our first term. Then we go and substitute 4, then 5, and we continue like that right up to substituting 10. Now we can see our first term is 19, then we have 24, we have 29, and it continues like that. So from here we can say that A, our first term, is 19. We have a constant difference this time because we add 5 every time. We do not know. When we now get to n, you need to be careful. Because we did not start by substituting in 1, 10 will not be the number of terms. We now need to think, if we started by substituting in 3, then 4, then 5, 6, 7, 8, 9, and 10, we actually only have 8 terms. A shortcut to calculate the number of terms is top minus bottom plus 1. So in our example, that would be 10 minus 3 plus 1, which will also give us the 8 terms that we had. Now we can finally substitute into our sum formula For an arithmetic series, we are going to calculate the sum of 8 terms. So n becomes 8. A, our first term, was 19. And our constant difference is 5. And that will give us a sum of 292. Example 4. Determine the value of m if the sigma is equal to 32,736. So in this case, they do not ask us to calculate the sum, but they give us the value of the sum. We start in the same way by expanding the series. So we're going to start by substituting in 2. Then 3. Then 4. And it will continue like that. Now we can calculate the first term's value is then 32, then 64, 128. From here we can now say that A, our first term, is 32. In this case we have a constant ratio because we multiply by 2 every time. We do not know the number of terms, but we do know that the sum of these terms will be 32,736. So now we can substitute everything we know into the sum formula for the geometric sequence. We know the sum, the value of A, the constant ratio, and once again the constant ratio. We now use algebra to solve this. So now we are going to rewrite 1024 as 2 to the power of 10, and this means that the number of terms that we add up will be 10. But now we need to remember that we need to solve m and not the number of terms. In the previous example, we heard that the number of terms can be calculated by saying top minus bottom plus 1, and we now know that that should equal 10 in this case. So we can say m minus 2 plus 1 is 10, which means m is 11. You can also be asked to write an expanded sequence in sigma notation. So to write in sigma notation, you need to be able to tell me where to start, where to end, and what the general formula or the general rule for that sequence is. Example 5. Write the following sequence in sigma notation. Now, if you have a look at this sequence, we can say that A is minus 3, and here we have a constant difference because we subtract 4 every time. With this information, we can now calculate the general formula by using the formula for a general term for an arithmetic series. We know that A is minus 3, and we know that D is minus 4. And when we simplify, the general formula is minus 4n plus 1. Now, when you determine the general formula in this way, you accept that you start with n is 1. So we can write part of our sigma notation already. We can say the general formula is minus 4n plus 1. And we get that when we start with n is 1. So we now still need to determine where to end. And for that, we're going to have a look at the last term because we know the value of that term. So in my Tn formula, which is minus 4n plus 1, we know the value of the last term is minus 123. And now with algebra, we are going to solve this. If we now divide by 4, we will get n is 31. And that means we will end at term 31. And this is the sigma notation for this given sequence.